Good morning, students. Now we are going to discuss about the basic operations on sets. Already we know that addition, subtraction, multiplication and division. These are the basic operations on numbers. These are the basic operations on numbers. Now we are going to define the basic operations on sets. These are the three basic operations on sets. The first one is union, and it will be represented by this symbol. And the second basic operation is intersection, and we denote it by this symbol. And third one is difference. We represent it with this symbol. So these three are the basic operations on sets, and this is the most important topic from this chapter, sets. Let us discuss each basic operation with some examples. So first we will start with union. Union of sets. The union of sets means it combines all the elements of given two or more sets into a single new set. Understand the definition. The union of sets means combines all the elements from the given two or more sets, and it should be written in a new single set, but it only includes each unique element once. Means each element should be considered only once, and the union is represented by this symbol. Let us see some examples. Consider set A as the best qualities of your friend. What are the best qualities of your friend? Optimistic, kindness, confident and caring. These four are the best qualities of your friend, and we are considering these four qualities as set A. Now set B, the best qualities of your brother. What are the best qualities of your brother? Politeness, confident and enthusiastic. So these three qualities are the best qualities of your brother, and we are considering these three as the elements of set B. Here we have defined two sets, set A and set B, with the best qualities of your friend and your brother. You have to acquire all the best qualities from your friend and brother. You want to acquire all the best qualities from your friend and brother. So then what will be your best qualities then? Means you have to consider all the best qualities from your friend and brother. So your qualities will become as, first you have to take the qualities from your friend, that is optimistic and kindness and confident. So first you have to acquire the qualities from your friend, that is optimistic and kindness and confident and caring. Caring. Afterwards, you have to acquire the qualities from your brother also. So you have to take the politeness, and next you have to take the quality confident, but you have already taken the quality confident from your friend, so no need to consider it again. Next you have to take the quality enthusiastic. So by acquiring the best qualities from your friend and brother, then you will be with these best qualities within you: optimistic, kindness, confident, caring, politeness and enthusiastic. This is nothing but the union of the two sets A and B. Means union means combining all the elements. Means here you have acquired all the best qualities from your friend and brother, those you have considered as set A and B. So you are taking all the qualities, means combining all the qualities in you. So this is nothing but A union B, union of sets. A union B means combining the elements from set A and set B, but here you have to consider each unique element only once. Means you have to write the element only one time. See, confident is the quality of your brother and friend, but here in A union B we have written it only once. Let us see one more example. Here we are defining set A as your favorite colors, that is red, blue and green. Means in set A, three elements are there: red, green, blue and green. Now defining set B as your friend's favorite colors. That is blue, yellow and purple. These are the three favorite colors of your friend. Here we have defined two sets, A and B, with the favorite colors of you and your friend. Now what is the set of all favorite colors between both of you? Set A is having your favorite colors and set B having your friend's favorite colors. Now we have to write a new set with all favorite colors of both of you. So it is nothing but the new set with having these colors: red, blue, green, yellow and purple. Means we have taken the favorite colors from you, that is from set A: red, blue and green. And next, favorite colors from your friend means set B. Blue already we have written in the set, so no need to write again. And yellow and then purple. So this is nothing but the union of sets A and B. So here A union B equal to the set of all the elements from set A and B: red, blue, green, yellow and purple. And here we have taken blue as only one time. Let us solve one more example. Here two sets are given. Set A is with elements 2, 5, 6, 8 and B is another set with elements 5, 7, 9 and 1. Now we have to find A union B. So we are going to find A union B. Let us write A union B equals to, so the first set is A. So write the elements of set A. So A equals to, with the elements 2, 5, 6 and 8, and next union symbol is there. So this is the symbol for union. And the next set B is there. So write the elements from set B. So the elements are 5, 7, 9 and 1. Now A union B equals to, now the result will be a single set with the elements of combining from these two sets. Means first let us write the elements from set A: 2 and then 5 and 6, and from set A another element 8. Now element from set B: 5 already exist in the set, so no need to write again. And then next element 7, and next element 9, and next element is 1. So this is the set A union B of given two sets. Now we have to represent this A union B as a Venn diagram. The universal set will be represented by a rectangle, and here we have to mention it as U. Sometimes we can write it as mu also, or you can represent it with U. The two sets will be represented as two circles. So consider this as set A and this as set B. Now we have to write the elements in these circles. First we have to write the common elements of two sets. What is the common element of two sets? 5 is the common element of the two sets. So 5 belongs to the both the sets. So you have to write the common element 5 in the intersection part, the combined part of the two circles. Afterwards, write the remaining elements. From set A, the remaining elements are 2, 6 and 8. And in set B, the remaining elements are 7, 9 and 1. Now, A union B means the combination, combining the two sets. So, shade the region which represent A union B. So this is the Venn diagram for A union B. Now another basic operation on sets, so that is intersection of sets. Intersection of sets. The intersection of sets is the set of common elements. The intersection of sets means it is also a set having common elements of given sets. For example, set A having people who like vanilla ice cream: John, David and Sarah. These three people likes vanilla ice cream, and we are considering them as a set A. Now set B with the people who like chocolate ice cream. So those are Emily and David. These two persons likes chocolate ice cream, so we are considering them in set B. Here we have taken two sets, A and B. In A, the people who like vanilla ice cream, and in set B, people who like chocolate ice cream. Now, who likes the both flavors of ice cream? Means the person who likes both vanilla ice cream and chocolate ice cream. Can you identify the person from set A and set B who likes both the flavors of ice creams, vanilla and chocolate? Yes, it is David, because he likes vanilla ice cream and he likes chocolate ice cream. So David likes both the flavors of ice cream. So this is nothing but the intersection of set A and set B. So intersection means the set of common elements of the given sets. Here set A and set B, David is the common element of these two sets. So we can write A intersection B is equals to David. This is the symbol to denote the intersection. So this represents A intersection B. We'll see one more example. Find A intersection B when A equals to, with elements 5, 6, 7, 8, and B equal to 7, 8, 9, 10. So we have to find A intersection B. Let us write as it is. A intersection B equal to, the first set is A. So we have to write the elements of set A, that is 5, 6, 7, 8, and then next we have intersection symbol. So this is the intersection symbol, and the next you have set B. Write the elements from set B, 7, 8, 9, and 10. And A intersection B equals to, this is a single set. So A intersection B equal to, here we have to write the common elements of these two sets. Common elements of these two sets, because here we are going to find the intersection. Common element of these two sets are 7, and one more element is also there, that is 8. These two elements belong to both the sets A and B. So A intersection B equals to 7 and 8. And let us go for the Venn diagram for this intersection. Universal set will be represented with a rectangle, and here we have to mention as U, means this is a universal set. And the two sets will be represented by circles. Let us consider the circle as set A and another circle as set B. Now we have to write the elements in the sets. First you have to write the common elements of two sets. The common elements of two sets are 7 and 8. So you have to write those elements here, 7 and 8. Means these two elements belongs to set A and at the same time to set B. Next we have to write the other elements from set A, 5 and 6, and the remaining elements from set B, 9 and 10. Now we have to shade the region where this intersection part lies. So the common part of two sets A and B, the common part of two sets A and B is this part. This is the common part for sets A and B. That part is nothing but the intersection. So we have to shade that region. This is the Venn diagram for A intersection B. If your life is a universal set and confident and hard work are two sets in your life, and what you will get by the intersection part of these two qualities, confidence and hard work. What is the intersection part of these two qualities in your life? Yes, the intersection part of confidence and hard work will give you success in your life. Another basic operations on sets, that is difference of sets. The difference of two sets denoted as A minus B. means it is the set of all elements present in set A but not in set B. So the elements of A minus B are should be present in set A but not present in set B. Let us see one example. Let define set A as the total students of a class. So the students are Alice, Bob, Charlie, David, Emily, and Frank. Total 6 students are there in the class. So that is we are considering it as set A. And set B is the students who are present at school today. So in the school 6 students are there. Now set B means the students who are present at school today. That is Bob, Charlie, David and Frank. These 4 students are present at school today. How many students are there actually? Total 6 students are there. And how many are present at school today? 4 students are there. And can you give the list of students who are absent today? Observe the set A and set B, and can you give the list of students who are absent to school today? Out of 6 students, 4 students are present to school. So the number of students absent is equals to 2. Who are the 2 students? Yes, the 2 students absent to school today are Alice and Emily. Here you can observe Bob attend the school today and Charlie also attend the school today. David also attend to school today. Frank also attend to school today. And Alice and Emily, these two are not present at school. So these two are absent to school today. So this list means this set is nothing but A minus B. Set A minus B. This is the difference of these two sets. So A minus B means the element should be present in set A but not in set B. Let us solve one more example. Here two sets are given A and B. A with elements 1, 2, 3, 4, 5 and B with elements 4, 5, 6, 7. Now we have to find A minus B. So A minus B equals to, first the set is A. So you have to write the elements of set A, that is 1, 2, 3, 4 and 5. And next minus symbol is there. So minus. And next you have set B. So write the set B elements here, set 4, 5, 6, 7, and A minus B equals to, so we have to write the elements. First you have to identify what are the common elements of those two sets. Common elements of those two sets. 4 is common for both the sets, so cancel that element, and 5 is also common for the both sets and cancel that element also. So first cancel the common elements from the two sets. Now write the remaining elements from set A, only from set A. So the remaining elements are 1, 2, 3, and no need to write the remaining elements from set B. Here we are taking only A minus B, means we have to write the elements from set A only, not for B. So after cancellation the common elements, write the remaining elements from set A. So this is A minus B, and U is the universal set. We are representing it with a rectangle, and the two sets are represented by circles. Consider the circle as set A and the circle as set B. Now we have to write the elements in these sets. First you have to write the common elements at the intersection part. So 4 and 5 are the common elements. First you have to write the elements. And next, what are the remaining elements from set A? Those are 1, 2, 3, and the remaining elements of set B are 6 and 7. Now you have to shade the part A which represents A minus B. Means from the circle A, you have to remove the part which also belongs to B. So this is the part one having elements 1, 2, 3. This part only you have to shade. So this is a Venn diagram for A minus B. Now for the same sets, let us find B minus A. So B minus A equals to, so here you have the set B at first. So you have to write the elements from set B, 4, 5, 6 and 7, and next minus symbol, and next you have set A. So write the elements from set A, 1, 2, 3, 4 and 5. So B minus A equals to, first you have to cancel the common elements from both the sets. The common elements are 4 and 5. These are the common elements from both the sets. Now write the remaining elements from the first set. First we have set B, so you have to write the elements from the set B. The elements are 6 and 7. So B minus A equals to set with elements 6 and 7, representing universal set with a rectangle and the two sets AB with circles, and here the elements are also here 1 2 3 4 5 and 6 7. Now we have to shade the region which represent exactly B minus A. B minus A means the elements from set B but not belong to set A. That means you have to remove the part of set B which also lies in set A. Yes, this is the shaded part to represent B minus A. This is the Venn diagram for B minus A. And if we observe these two answers from set B minus A and A minus B, we have A minus B is with elements 1, 2, 3, and B minus A with the elements 6 comma 7. Both the elements are different, and from the diagram also you can easily observe the shaded part of A minus B and the shaded part of B minus A, both are different. So we can conclude that A minus B is not equals to B minus A. A minus B not equals to B minus A. Let us solve one more question. Set A equals to x is a prime number and x less than 10, and b equal to x such that x is a factor of 6. Here the two sets are given in set builder form. We have to write the elements for that sets first. So set A equals to, here we have to write the prime numbers less than 10. The prime numbers less than 10 means they are 2, 3, 5 and 7. And the next set B equals to, here we have to take the factors of 6. What are the factors of 6? 6 will be divisible by 1 table, means 1 6 are 6, and it is also divisible by 2 table with 3. 2 3s are 6. The factors of 6 are 1, 2, 3 and 6. So in this way we have to write the roster form of the given sets first. For these sets, we have to find A union B, A intersection B, A minus B, and B minus A. Let us first find A union B. So A union B equals to, first write the set elements from set A, 2, 3, 5, and 7, and union of, and next you have to write the set B. So elements 1, 2, 3, and 6. Then A union B is equals to, set of union means combining all the elements for the of that these two sets. So write the elements 2 and 3 and 5 and 7 elements from first set, and next elements from the next set. 1, 2 we have already written in this set, so no need to write again. Next element 3, that is also written already in the set, so no need to write this one also. Next write the next element 6. So this is the union A union B of given sets, and this is a Venn diagram for A union B. Here we have to shade the region which represent A union B. The shaded part represents A union B, and if you observe the elements in the shaded region, that will be exactly equal to the answer here which we have written as A union B. Next we will find A intersection B. A intersection B equal to, first write the elements of set A, that is 2, 3, 5, 7, and next intersection symbol, and the next elements from set B, 1, 2, 3 and 6. then A intersection B equals to, intersection means the common elements of two sets. Identify the common elements of two sets. What are the common elements in both the sets? 2 and 3. These are the common elements of two sets. So the A intersection B is nothing but 2, 3. Now shade the region which represent A intersection B. So this part in represent the A intersection B. Now let us find A minus B. So first set A is there. Write the elements of set A: 2, 3, 5, 7 minus, and next we have set B. So write the elements of set B. Those are 1, 2, 3 and 6. So A minus B equals to write the elements of A minus B, first you have to cancel the common elements from both the sets. So 2 is the common element and 3 is also common element of both the sets. So write the remaining elements from the first set. So those are nothing but 5 and 7. This is A minus B. Now shade the region which represents A minus B. So this is the part represents A minus B. In the same way, we have to find B minus A. Here we have set B at first. So we have to write the elements of set B: 1, 2, 3, 6 minus set A. Set A means 2, 3, 5, 7. So to find the B minus A set, first of all, we have to cancel the common elements from both the sets. There are 2 and 3. Now write the remaining elements from the first set. So 1 and 6, these are the elements. So this is B minus A. Now this part represents the B minus A. So in this way we have to find A union B, A intersection B, A minus B and B minus A for the given two sets. And from these Venn diagrams, observe that the position of sets and elements of the sets will be same in all these four Venn diagrams. Only the shaded region will be different. If you observe in A union B, both A, B sets are shaded. So in A union B, only the part having elements 2, 3 is shaded. In A minus B, the part having elements 5, 7 is shaded. In B minus A, only the part of B having elements 1, 6 is shaded. So the position of elements will not be changed. Only the shaded region will be changed for these four Venn diagrams. This is the most important question for the public examinations. Let us discuss about one more topic: disjoint sets. Disjoint sets are the sets which have no common elements. Means the sets which have no common elements are called disjoint sets. For example, here two sets are there. A equals to having elements 1, 3, 5, 7 and set B with elements 2, 4, 6, 8. So if we observe that, is there any element common for both the sets? Is there any element which belongs to set A and set B? No. No elements are there in common. So we can write A and B are disjoint sets. If we find A intersection B for these two sets, what we will get? So let us try to find it. A, set A means elements 1, 3, 5, 7 intersection, and then set B means 2, 4, 6, 8. So A intersection B, A intersection B. Intersection means writing the common elements, but these two sets have no common elements. So A intersection B is a set which having no elements. So no elements means it is nothing but an empty set. Means the intersection of disjoint sets is nothing but an empty set. Empty set. And what is the cardinal number of this intersection part? N of A intersection B means number of elements of this intersection A intersection B. It has no element, so its cardinal number is nothing but 0. So the intersection of disjoint sets is an empty set and its cardinal part number is nothing but 0. From exercise 2.2, let us solve this question. State whether the following statements is true or false. Justify your answers. So from the first question, two sets are given with elements 2, 3, 4, 5 and 3, 6. Now here stating that these two are disjoint sets. Disjoint sets means they should have no common elements. But here 3 is the common element for both the sets. So these two are not disjoint sets and the given statement is false. For the second one, A, E, I, O, U and A, B, C, D are disjoint sets. Disjoint means they should have no common elements, but element A is the common element for both the sets. So this statement is also false. And third one, two sets with elements 2, 6, 10, 14 and 3, 7, 11, 15. These two are disjoint sets. Yes, they don't have any common element. So this statement is true. And fourth one, 2, 6, 10 and 3, 7, 11 are disjoint sets. This statement is also true because they do not have any common element. And let us try to draw the Venn diagram for the last question. And here universal set is represented by a rectangle and the two sets will be represented as a circle like this, and the elements of the first set are 2, 6, 10, 2, 6, 10, and the elements from the second set are 3, 7, 11. So these two are the disjoint sets. So the Venn diagram should be like this. You should not join these two circles because they have no common elements. Whenever the sets have common elements, then only you have to combine these two circles. But here these are disjoint sets. You should draw the circle separately for the disjoint sets. Remember the sets A minus B, B minus A and A intersection B are always mutually disjoint sets. Let us prove this with one example. Let us take two sets A and B with the elements A 2, 4, 6, 8, 10 and B with elements 3, 6, 9, 12, 15. We can take elements as our own. So now first we have to find A minus B. So A minus B equals to, write the elements of first set 2, 4, 6, 8, 10 and minus of, and the elements from second set B 3, 6, 9, 12 and 15. So now what is A minus B? A minus B equals to, first of all you have to cancel the common element from both the sets. 6 is the common element from both the sets. Write the remaining elements from the first set. So the elements are 2, 4, 8 and 10. This is A minus B. Now what is the Venn diagram for this one? So this is a universal set. You can represent it with U or sometimes you can write it as mu also. So these two circles are represents the two sets A and B. So now you have to write the elements here. The elements, common element of the two sets is 6. What are the remaining elements of set A? 2, 4, 8 and 10. And what are the remaining elements from set B? 3, 9, 12 and 15. Now we have to shade the region which represent A minus B. So this part represent A minus B. Now let us find B minus A. Here we have the set B at first. So write the elements of set B. Elements 3, 6, 9, 12, 15 minus, and another set. Next set we have set A. So the elements from set A 2, 4, 6, 8, 10, that is equals to B minus A equals to, here you have to cancel the common element from both the sets. 6 is the common element, and now write the remaining elements from first set. So those elements are 3, 9, 12 and 15. So this is B minus A. Now we have to shade the region from the diagram which represents B minus A. Yes, this part represents B minus A. Now let us find A intersection B. So A intersection B means first write the elements from set A, 2, 4, 6, 8 and 10, and intersection of, next we have to write the elements of set B, 3, 6, 9, 12, 15. So A intersection B equal to A intersection B means we have to write the common element of both the sets. Intersection means common element. So we have only one common element from both the sets. So we have to write the common element 6 as A intersection B. Now which part of the diagram represent the intersection part? So this is the intersection part. If we observe here the elements of A intersection B, A minus B, B minus A and A intersection B. See, A minus B is having elements 2, 4, 8, 10, and B minus A is having elements 3, 9, 12, 15, and A intersection B having elements 6. So there are no common elements from A minus B, B minus A and A intersection B. So we can say that these three sets A minus B and B minus A and A intersection B are mutually disjoint sets. From the diagram also you can observe that this part represents A minus B and this part represents B minus A, and this common part represents A intersection B. So these three sets are mutually disjoint. They have no common elements. Do you know what is the relationship between n of A means the number of elements in set A, n of B number of elements in set B, n of A intersection B number of elements in A intersection B, and n of A union B number of elements in A union B. So what is the relationship between these four numbers? This is the relationship of those four numbers, that is n of A union B equals to n of A plus n of B minus n of A intersection B. Let us prove this with one example. Let us solve this question. Set A equals to x such that x is a prime number less than 10 and B is x such that x is a natural number less than 6. So the sets are given in set builder form, we have to make it in convert it into roster form. So A equal to x is a prime number less than 10 means the prime numbers less than 10 are 2, 3, 5, 7, and B equal to set x such that x is a natural number less than 6 means we have to write the numbers up to 5, 1, 2, 3, 4, 5. It is less than 6 not equal to 6. So these are the two sets given. Now we have to verify this formula n of A union B equal to n of A plus n of B minus n of A intersection B. So first we have to find n of A. Here set A having 4 elements, so we can write n of A equal to, n of A means the number of elements in set A. It has 4 elements 2, 3, 5, 7. So n of A equal to 4. And next we have to find n of B. So n of B equal to the number of elements in set B. So it has elements 1, 2, 3, 4, 5. Total 5 elements are there. So n of B equal to 5. Next we have to find n of A union B. To find that one, first we have to identify what is A union B. So A union B equal to, first write the elements of set A, 2, 3, 5, 7 union, and B means 1, 2, 3, 4, 5. So A union B equals to, A union B means combining all the elements of two sets. That means you have to write the elements from the first set 2, 3, 5, 7, and elements from the second set also. So 1, 2 we have already taken in the set, 2 is also there. So next you have to write the element 4, 5 is also already written in the set. So A union B is 2, 3, 5, 7, 1, 4. Now what is n of A union B means number of elements of the set A union B. How many elements are there? 1, 2, 3, 4, 5 and 6. So n of A union B equal to 6. Next we have to find n of A intersection B. So for that, first we need to find A intersection B. A intersection B means first write the elements of A, 2, 3, 5, 7 and intersection of, next write the elements of set B. So that is 1, 2, 3, 4, 5. So A intersection B equal to, A intersection B means you have to write the common elements of both the sets. What are the common elements? 2 is the common element of both the sets and 3 is also common element of both the sets and 5 is also common element of both the sets. So the common elements of both the sets is nothing but 2, 3 and 5. So what is n of A intersection B here? N of A intersection B means the number of elements of A intersection B. Here 3 elements are there, 1, 2, 3. N of A intersection B equal to 3. Here we have n of A union B and n of A and n of B and n of A union B and n of A intersection B. Let us substitute these values in this formula. So what is n of A union B? N of A union B value is 6 and next equals to symbol is there, equal to, what is n of A? N of A value is 4 and next plus symbol is there, and n of B, what is n of B value? It is 5 and minus symbol is there, minus, next n of A intersection B, n of A intersection B value is 3. So 6 equals to, what is 4 plus 5? 9 and 9 minus 3 is nothing but 6. So both the values on left side and right side are equal. So this formula is true for all the sets A and B, that is n of A union B equals to n of A plus n of B minus n of A intersection B. If three sets are given, suppose A having elements 1, 2, 3, 4 and B with elements 3, 5, 7 and C 2, 4, 6, 7. Three sets are given. Now we have to find A union B intersection C, and the second question A union B intersection A union C. So let us try to solve the first question. To solve this one, A union B intersection C, first you have to complete the part which is in the bracket. So first we need to find B intersection C. So B is the set with 3, 5, 7 and C is 2, 4, 6, 7. Now B intersection C means element with 7, because 7 is the common element for both the sets. Next we have to make union of set A and B intersection C, union of these two sets. So A union B intersection C means first you have to write the elements of set A union and next you have to write the elements of set B intersection C. So this is B intersection C. Now union of these two sets means combining all the elements of these two sets. So the answer is A union B intersection C means 1, 2, 3, 4, 7. So from this first you have to find B intersection C. Afterwards you have to do A union of this set. In the same way, let us find the solution for the second question. So to solve this one, first you have to complete the terms which are in the bracket. First you need to find A union B and then next A union C. Afterwards you have to do the intersection of these two sets. So this is A union B. So A union B means elements of set A and set B, the combination combining all these elements, that is 1, 2, 3, 4, 5, 7. And this is A union C. This is A union C means that is combination of set A and set C. So the combining all the elements from these two sets. So the result is 1, 2, 3, 4, 6, 7. Next we have to do the intersection of these two sets, A union B intersection of A union. Now this is A union B intersection A union C. Means first you have to write the elements of A union B, and next you have to write the elements of A union C, and you have to do the intersection of these two sets. Means common elements of these two sets. Intersection means the common elements are 1, 2, 3, 4 and 7. The complement of a set. The complement of a set A is the collection of all elements of the universal set, but that elements are not in the given set A. The A complement means we can represent it as like this, A complement. So that is equals to, we have to write the all the elements of set E, universal set, that means U, and that are not in the given set, means the formula to find the complement of set A complement equals to U minus A. So in the same way, if the set is B, so B complement means it is U minus B. And if you want to find C complement, that is U minus C. If you want to find A union B complement, so the formula is U minus of A union B. If you want to find A intersection B complement, so the formula is U minus, U means universal set, minus A intersection B. So for which set you want to find the complement, you have to subtract it from the universal set U minus that set. Means here you have to do the operation difference. Let us see one example. The universal set U is given with elements 1, 2, 3, 4, 5, and the set A equals to 2, 3. So A complement equals to, the formula A complement equals to U minus A. So U minus A means first you have to write the elements of set U, that is 1, 2, 3, 4, 5, and minus, and next you have to write the elements of set A. So 1, 2, 3, 4, 5 minus of 2, 3. What we have to do for the difference operation? We have to cancel the common elements of both the sets. 2 and 3 are the common elements of the both the sets. So then the result is nothing but the remaining elements of the first set. So it is 1, 4, 5. This is nothing but A complement. So A complement equals to, with the elements 1, 4 and 5. And to draw the Venn diagram, let us first draw a rectangle which represents the universal set, and the circle is nothing but the set A. Here we have only one set A, so we have to draw only one circle. And what are the elements of set A? 2 and 3. Okay, so what are the elements of a universal set? 1, 2, 3, 4, 5. But this circle already lies in the rectangle, means in the universal set, means 2, 3 already we have written. So you have to write the remaining elements 1, 4, 5 outside of the circle. So 1, 4, 5. So if you observe in the rectangle, the elements are 1, 2, 3, 4, 5. In the circle, only 2, 3 are there. Now we have to shade the region which represent the A complement. A complement means the elements of the universal set except from the set A, means the elements of universal set other than set A. So this part represents the A complement. Here you can observe the shaded part having the elements 1, 4, 5, which represents the A complement. Let us solve one question from exercise 2.2. Second question. The given set A is with elements 0 to 4, and now we have to find A intersection 5 and A intersection A. So A intersection 5 equals to, first we have to write the elements of set A, that is 0 to 4, and intersection of next set is 5. 5 means empty set, means no elements in that set. So that is equals to A intersection 5 equals to Intersection means we have to write the common elements of these two sets. So can you observe or can you identify any common element of these two sets? No, no common elements for these two sets. So A intersection 5 is also empty set. So A intersection 5 is equals to 5 empty set. And next we have to find A intersection A. So that is equals to, first we have to write the first set A, that is 0 to 4, and next intersection of, and again the second set is A only. So write the elements of A 0 to 4. So that is equals to A intersection A equal to, what are the common elements from these two sets? The common elements are 0, 2 and 4. All three elements are common. So A intersection A is nothing but the set with having 0 to 4 is nothing but the given set A. So A intersection A is nothing but A. So by observing these results, the first one A intersection 5 is nothing but 5 and A intersection A is nothing but A. What we can conclude from the first answer, we can say that the intersection of any set with the empty set is always the empty set. And from the second result, we can say that the intersection of a set with itself is the set itself. Now let us solve the fourth question. What is given here? If A and B are two sets such that set A is subset of B, then what is A union B? Explained by giving an example. Let us consider set A equals to elements 2, 3, 5, and let us consider the set B with the elements 1, 2, 3, 5 and 7. Now, what is the given condition here? A subset B. If you observe that the elements of A, that is 2 and 3 and 5, all the three elements of A belongs to set B. That means we can say that A is subset of B. Okay. So now by satisfying this condition A subset of B, now we have to find A union B. So A union B is equals to, first I'll write the elements of set A, that is 2, 3, 5 and union, and next elements of set B 1, 2, 3, 5 and 7. So A union B, union means you have to combine all the elements of the two sets. So we can write the elements from first set 2, 3 and 5 and elements from the second set. 1 we have not taken, so let us write here. 2 we have already written, 3 already written and 5 is already there in the set. Now you have to write the next element 7. So this is the result A union B. So if you observe that A union B equal to the elements with the set with these elements 1, 2, 3, 5, 7 is nothing but the set B. So the result is nothing but set B. So A union B is nothing but B, where A subset B. So what we can conclude with this result? So if A subset B, then A union B equals to B. Then what is the Venn diagram for this set? And this rectangle represents the universal set U, and here we have two sets A and B, so we have to draw two circles, but the given condition is A subset B. That means all the elements of set A are present in set B. So the set A, the circle represents set A, should be inside the circle of set B. If A subset B means we have to draw the circles like this. Now the elements of set A are 2, 3 and 5. What are the remaining elements of set B other than 2, 3, 5? The elements are 1 and 7. So if you observe that the set A having 2, 3, 5, the set B means having 1, 7 along with 2, 3, 5. Now A union B means you have to shade the region which is the combination of these two circles, means two sets. So this is the shaded region which represents A union B. So if we observe, this total shaded region is completely lies inside the circle, means set B. So the result A union B is equals to B. And also remember that if A subset B, then A intersection B is equals to A. If A subset B, then union will be set B and their intersection will be set A. And try to solve the remaining questions from exercise 2.2. Try to solve these questions from SSC previous public examination papers for 2 marks, 4 marks and 6 marks.